Today we're going to talk about direct and inverse variation. You've already seen direct variation. Hopefully you remember that it was the oblique line that went through the origin. Now we're going to add to that. We're going to add inverse variation. So an example of neither, though, first would be like y equals mx plus b, where b is an integer. Y equals x squared, y equals the square root of x. Okay, so if we were to graph y equals x squared, let's see. Okay, so that's not going to be a direct variation or an inverse variation. Direct variation is something is proportionate, like your proportions. Inverse variation is inversely related. You might see it in chemistry with Boyle's law. Anyways, back to the neither. It's you know, this one it's not at all going to be direct variation, and I'll show you why it's not inverse variation as we get there. So to the direct variation, couple of things. The formula is y equals kx. We also talked about it being a the ratio of two numbers equals a constant, so y over x equals k, or x over y equals k. Those are your direct variations. They go through the origin. And it's an oblique slanted line. Okay, now inverse variation is basically as one variable increases, the other decreases. In direct variation, as one variable increases, the other one increases, or if they both decrease, then that's direct variation. Inverse variation is as one variable increases, the other decreases. So for direct variation, as x increases, y increases, or as x decreases, y decreases. In inverse variation, as x increases, y decreases, or as x decreases, y increases. So this formula is xy equals k. Notice it's different. I'm not saying it's a ratio anymore. It's the product of the two variables equals a k constant. Now remember, k is a constant. Another form might be, you know, y equals, if it was solved for y, it'd be y equals k divided by x, or it could be x equals k divided by y. And another formula that we sometimes use is x1, y1 equals x2, y2, because they would both have to be equal to the same constant, and that's good if you're talking about like coordinates. An example on the direct variation could be, you know, like y equals 1/3 x. So we start here, we go up 1 over 3, and then I'd go back 3 down 1. So this is your direct variation, y equals 1/3 x. This one was y equals x squared. So the inverse variation, if you look at it, I can let k be any value. So the constant that I chose on the direct variation was 1/3. I'm going to choose something a little bit differently on this one. I'm going to choose xy equals 6. Now if I'm going to set up a table of values on that, I would have 2 times 3, 3 times 2, 1 times 6, 6 times 1, negative 2 times negative 3, negative 3 times negative 2, negative 1, negative 6, negative 6, negative 1. I chose values that are easy to plot. So now I'm going to go over 2. Here's my center. Somehow this y-axis is off here. Let me see if I can fix that. There we go. Okay, so over 2, up 3, and then 3, 2, 6, 1, 1, 1, 2, 3, 4, 5, 6. All right, now if you think about it, in the chart, can I have x be 0? 0 times what equals 6? Is there anything? No. How about, can I let y be 0? Is there anything 0 times anything that will equal 6 so that the y's could work out? No. So in that instance, we cannot have x or y be equal to 0. So we do these asymptotes. We've seen these before. This is where it's undefined. It's undefined at x equals 0. And we said we couldn't get the y to equal 0. So these are called asymptotes. A-S-Y-M-P-T-O-T-E. And so it's undefined at y equals 0 as well. So when I go to graph this, it never crosses that. So it kind of just hugs it. Hugs those axes. And then when I plot into quadrant 3, negative 2, negative 3, negative 3, negative 2. Same thing. It just goes like that. So that's what your graph will look like for an inverse variation. I'll show you another one. There's another one at the end of the lesson that's a little bit different, but same idea. Now let's talk about the domain here and the range. Now this one, the domain was all reals, and the range was y is greater than or equal to 0. On the oblique line, that's all reals for the x's and all reals for the y's. But on my inverse variation, that domain is x not equal to 0, and my range is y not equal to 0. Okay, so tell whether the variables vary directly, inversely, or neither. So on his way to work, Randy travels 10 miles at r miles per hour for 8 hours. So there is a formula, distance equals rate times time. And I've got Randy travels 10 miles. So I put my units. And my rate is miles per hour, so it's going to be r miles per hour times the time, which is h hours. Now I know this is right because the units hours cancel, and I'm left with 10 miles equals r miles times h. And so I want the units on the right-hand side to cancel like this so that I'm doing the units miles equals miles. So my equation would be 10 equals r times h. Well, if you look up above, that's an inverse variation. And if we think about it, if I make my rate faster, all right, and the distance is 10 miles is going to stay the same. If I make my rate faster, the hours to get there is going to be less. So as r increases, if I change my speed to go faster, it's going to take less time to get there. That's inverse variation. Direct variation would be if I increase the rate and then the hours got longer, but that's not happening. Each day, Jamie works for 6 hours typing P pages of a report at a rate of m minutes per hour. So we have a rate of m minutes per hour, and the rate is, again, you know, it's kind of like distance equals rate times time, but it's going to be work equals the rate times time. So I'm going to do 6 hours equals the rate, and it was m minutes per page times P pages. So you see here how the pages are going to cancel. And then I have another problem. I got hours. We're in minutes, so I should convert that 6 hours to, you know, 1 hour is 60 minutes. So 6 hours should be 6 times 60, which is 360 minutes. So 360 minutes equals m minutes times P. And we've got the minutes matching up. So basically the formula is 360 equals m times P. That is, again, inverse variation. So I am working for 6 hours. That's my constant. That's not changing. But if I go faster, then a rate of m minutes per page, then if I go, like, you know, faster, if I get a rate of m minutes per page, then I'm going to get P pages. Okay, so let's say I did 6 pages. That would be 60 minutes per page. But if I increased P to 12 pages, then I would get 360 divided by 12, which would be 30 minutes per page. So as the 6 goes to 12 for pages, that increases. The rate went 60 to 30. So it was 60 minutes per page versus 30 minutes per page, which is kind of faster, but that number decreases. So it's inverse variation. Number 3, you take a limo to the prom, and the limo company charges $600 for P people at C cost each person. So again, I would think that it would be 600. Okay, I would think it would be $600 equals P people at, now I always put the rate, C cost to each person. So it's going to be C, it's going to be dollars per, so it's going to be dollars per people, I think. And then there's going to be P people. So the people rate's going to cancel, and you're going to be left with those units that are the same. So the dollars are the same. So it should be 600 equals C times P. So if you have, for example, let's say you have 2 people, then the cost is going to be $300 each. But if you increase to 6 people, so the P is increasing, then the cost per person goes down to 100. So as the P is increasing, the C is decreasing. This is inverse variation. All right, number 4, A, the amount of a cell phone bill is 25 plus 10 cents a minute M. So that would be A, the amount, is equal to 25 plus 10 cents a minute. So it's going to be 0.10 M. That's neither. And this number 5 is also neither. I'm going to add a number 6 on there. If I took the one of the ones up above and I said, Jamie works for M minutes, typing P pages, at 2 minutes per page. So what is that? So if we kind of look at up above, I did hours, and this time I just changed it to M. So I'm saying M minutes equals, now my rate is the thing that's constant, so I'm doing 2 minutes per page times P pages. And again, notice how the pages cancel. And I'm left with M minutes equals 2 minutes. So I want those rates to be the same, or the minute to be the same. So M equals 2P. So in this instance, as P increases, so would M, and vice versa. So this is direct variation. Okay? Because the rate is staying the same. All right, next page. So here's some word problems. This is something that I could relate to when my kids were little. Grandma Krieg has discovered that her enjoyment of Kathleen and Maria's Barney video varies inversely. So there's the key word. As X increases, Y decreases, or vice versa, to the number of times she has watched it. In her third viewing of the video offered only 84% enjoyment. How much did she enjoy the 12th showing? So you could say then that if her third viewing of the video only offered 84% enjoyment, how much did she enjoy the 12th showing? So we kind of have third, 84%, 12th, and how much did she enjoy? So we're looking for the percent. So we're looking for X percent. That's what we're looking for. So this one looks like it's kind of a proportion, but it's not because it says inverse variation. So I could use that formula, X1, Y1 equals X2, Y2. So this could be X1, the 84%. I'm going to convert it to a decimal. And then Y1 could be the third showing, because we're talking about a different, now we're talking about different things, so it needs to be a different variable. So that could be 3. And then X2 could be the 12th. Oh no, this is X2 right here, the percent. This would be Y2, the 12th. So X2 is what we're solving for. What percent is that? And times 12. So what we're saying is as 3 goes to 12, the percent should go down. So 3 times 0.84, we need to get that, is 2.52, 12x, and then we're going to divide that by 12. And so I get X is equal to 0.21, which is 21%. So that should make sense. That when you were little, you probably, I know I remember doing it too. You wanted to watch a show over and over and over, and your enjoyment increased as you watched it. But an adult's enjoyment does not, and I'm sure you're that way now, where the third viewing of it, you had 84% enjoyment. By the 12th, you're going to lose interest, so your enjoyment should go down. So as one of the variables increased, the other decreased. Number 6, TJ's Brickworks found that within reason, the number of workers on a job varies inversely. There it is again, to the time needed. So as X increases, Y decreases, or as X decreases, Y increases. Time needed to finish project. If 4 workers can complete a brick patio in 20 hours, how many workers are needed to finish the job in 5 hours? So again, I've got 4 workers in 20 hours are needed to finish the job in 5 hours. So this formula kind of works out, but you could do it with xy equals k. I'll show you that way also. So you could say that the first xy scenario is the workers and the hours. So that would be 4 workers times 20 hours equals a constant of 80. And then you can do it again, but now you're going to plug 80 in for k, and you're going to plug in 5 where the hours were plugged in, which would be for y. And we're still looking, so we're looking for x. So 5x equals 80 divided by 5, so x would be 16. And we are talking about, it should make sense. We've got 4 workers can complete a brick patio in 20 hours. If we slow down the job to 5 hours, it's going to mean that we had to 5 hours. Actually, we didn't slow it down. We sped it up. We took less time to do the job. So you should increase your number of workers from 4 to 16. Okay? Or you could do x1, y1 equals x2, y2. So this was step 1, this was step 2, this one you do it all in one step. So it's 4 workers times 20 hours equals how many workers times 5 hours. So there's the 80 and the 5x, and x is equal to 16. You do not set up a proportion. It is not a direct variation. Sketch the graph of the function xy equals -8. So I don't need my calculator, but if you do, you could do y equals -8 over x. I can just plug in -4 and 2 and know those multiply to -8. I could do +4, -2. I can do -2, +4, +2, -4. I can do a whole bunch. 8 and -1, -8 and 1, 1 and -8, -1 and 8. So I'm using the easy ones. So 1, 2, 3, 4, 1, 2, over 2, 1, 2, 3, 4. Now we're just in different quadrants when we make the constant negative. So we're going to now have those asymptotes be along the x and y axis again. And then when we plot over here, so there's the graph. The domain is x not equal to 0. The range is y not equal to 0. There's no way I can have x be 0 and have it multiplied by something equal to -8. Same thing with the y. Okay.